All right, we have dealt with absolute value equations. Now we're going to deal with absolute value inequalities. That means less than, greater than, less than or equal to, greater than or equal to. These get a little tricky, and I want to fix something before we even begin. Solve each inequality. Man, that typo there, that's drastic. And graph all the possible solutions on a number line. So on the previous lesson, when we were writing our answers, we would just say, oh, x equals this and x equals that, like x equals 3 or negative 3 and those kinds of things. Now we're going to have an infinite number of solutions, and the best way to represent it is with a number line and with some inequalities. So I think one of the best places to start actually is with the table of values. So let's pick a different color. What color do you want? Purple? Sounds good. I'm going to say x is here, and then I'm going to put the absolute value of x is less than or equal to 1, and I want to put a little question mark. So this may not be the way mathematical textbooks do it, but I'm going to do that. So here we go. Let's pick a few numbers. I'm going to pick -2, -1, 0, 1, and 2. And I'm going to plug those numbers into this, and I'm going to see if this is a true statement or a false statement. Okay? So the absolute value of -2, the absolute value of -2 is less than or equal to 1. Okay? That would be 2 is less than 1. That is false. Okay, so my little table's already getting a little cluttered, but that's okay. But we just came up with a false statement. Okay, well, let's try this one. Absolute value of -1 is less than or equal to 1. Is this true or false? Well, that gives me 1, and 1 is equal to 1, so this one's going to be true. So now we'll plug in a 0. Absolute value of 0 is less than or equal to 1. 0 is less than 1, that's true. Okay, this is now going a little faster. Absolute value of 1 is less than or equal to 1, and let's see, 1 is equal to 1, so that's true. And then the absolute value of 2 is less than or equal to 1, and so let's see, 2 is less than 1. Ooh, that must be false. Okay, so we have come up with a little list of values that some of them work, some of them don't, and so we can go ahead and draw a little number line. Let's draw a number line right here. And that number line is going to have these same numbers on it. So we'll put a 0 and a 1 and a 2 and a -1 and a -2. And then we're going to grab a pen and we're going to start coloring. And I'm going to say, you know what? 0 satisfies this inequality. Yeah. 1 satisfies this inequality. 2 does not, so don't even touch it. Okay? -1 satisfied this inequality. -2 does not. Okay, so now we've got a few points on there. We have 3 points that were all true. And now I'm going to think about what really happens around them. So think about this. Ponder this with me, will you? If I had more space here and wanted to expand this, and I put 1/2. 1/2. Let's see. 1/2, absolute value is 1/2. 1/2 is less than 1. Oh, that'd be true. So 1/2 is true. How about 0.75? So 3/4. 0.75 is less than 1. Well, that's true. 0.9 goes here. 0.9 is less than 1. Well, that's true. And so all that would be true. Anything between 0 and 1 is true. So yeah, that gets shaded. Then I'm going to think about what happens over here on the negative side. And the negative side is really going to be reflected. It's going to be the same thing over here. So -1/2 becomes positive. Positive 1/2 is less than 1. So that's true. And then the same thing here and the same thing here. So we have that situation. I wonder if we're finished with our graph or not. That's important to know. Let me get this piece of paper out from underneath. And so let's think if it goes beyond these borders. 1/2. 1/2. 1/2 is less than 1. No, it's not. So don't do that. 1.1 perhaps? 1.1 less than 1? No. How about -1.1? -1.1, well, it becomes positive, and it's not less than 1, so that's a no. This is my full graph. That's it. This is the set of all solutions graphed on a number line. So one more little thing we're going to do, we'll do it in green, and it is going to be an inequality that represents what we're looking at right here, and here it is. From -1 to 1, and x is between them, and you've seen this before. Between them and including that. So basically what I just did was I looked at this inequality and I found the solutions that work with it. Okay? All right, we're about to expound on this idea, or expand this idea a little bit, and we could do that by going greater than, or we could do that by going less than. This one was less. Which one do you want to do? You want to switch gears, or do you want to do a similar one? Giving you an option in a video, and in a minute, I'm just going to pick one anyway. Let's slide down. Here we go. If you want to make a table out of this, you totally could, but I want to point at something and sort of demonstrate what's going on here. If the absolute value of x is less than or equal to 1 and the answer ended up being this, then I can do the exact same thing right here. So, follow me closely. Notice that this 1 could have been 1 or negative 1. So this 2 could be 2 or negative 2. And this less than or equal to basically means that we had an x in between them. So, oops, it's not equal. This one's not. That one was equal. This one is not. So there's that. And then the stuff in the absolute value, in this case was x. In this case, it's x plus 1. And so the way I used to teach this was you're going to make a sandwich. And here's your sandwich. If you have a number here and a less than there, then you're going to make a sandwich out of that positive number. It has to be a positive number. So we're going to encounter a problem here in a second. So with this positive number, we'll do 2 and negative 2, or we'll do 1 and negative 1. And we're going to make a little sandwich out of it. So these are the slices of bread. This is all the stuff inside. This is your ham and your cheese and your lettuce or whatever. And then this is the mayonnaise that goes on one. And then this is the, I don't know, tartar sauce or horseradish that goes on the other. Peanut butter, I don't know. Anyway, so this is the bread, this is the cushion, the condiments, and then this is the inside of it, okay? So let's solve this, and I am going to show the work on this one. So let's subtract 1 from this side of the inequality, and this side of the inequality, and this side. Oh, there's a 3-sided inequality here. So I'm going to have in the middle x less than, so 2 minus 1 is 1, negative 2 minus 1 is negative 3. And we now have an answer that looks very similar to this one. And so when I draw it on a number line, when I graph it on a number line, I can get all technical and just test all the numbers. Does this work? Does that work? I don't know. If I plug this in, does it work or not? Negative 3, positive 1, and let's draw. Okay, first of all, these were equal, so these circles got filled in. These are not, so you don't. It's that simple. And then I'm going to just simply shade in between. Okay? So far we have learned one type of problem, and that type of problem is less than. I think that's important, so I'm going to just come over here and I want to point out that these are less than. This one's less than or equal to, but the main idea is there, that these are less than. Less than, and if you're going to work them out by hand, this is how you would do it. Good skill to have. Can we Desmos it? Why would you want to do that when you can learn it by hand? Really, good skills to have, because if you know these skills, then you're gaining some understanding of what absolute value truly represents. For example, I could plug in a 0. 0 plus 1 is less than 2. I could plug in a negative 2. All right, plug in a negative 2. Negative 2 plus 1 is negative 1. Make it positive. 1 is less than 2. We're good. So it gives me an understanding of the structure of things, kind of helps me see that, particularly with this structure as well. Like this value is between those two. All right, the way we started this video was with a little table of values that goes with that. We're going to do the same thing right here, and this is going to get very cluttered if I don't put a little dividing line between these two types of problems. Now, if you're like, what about that guy? Well, forget him. Actually, let's not forget him. I'm not going to do it. I'm just going to point at it. Stare at it for a second. Think about it logically. You already know the answer to this one. You do. Moving on. Okay, just wanted to give you a taste of what's to come. This next one looks exactly the same, but it's quite different. Bad grammar. Quite differently. So absolute value of x is greater than or equal to 1. Is that true or false? Okay, and we're going to use the same numbers, negative 2, negative 1, 0, 1, 2. And we're going to plug those in. I probably should have spaced them out a little more because I've got a lot of writing to do. So the absolute value of negative 2 is greater than or equal to 1. Is that true or false? Well, that would be 2 is greater than 1, so that would be true. Okay. Let's see. Absolute value of negative 1 is greater than or equal to 1. So 1 is greater than or equal to 1. Well, it is equal, so that one's going to be true. Absolute value of 0 is greater than or equal to 1. 0 is greater than 1. No, that would be false, my friends. Absolute value of 1 is greater than or equal to 1. 1 is equal to 1. That's true. And absolute value of 2 is greater than or equal to 1. So this one's going to be true as well. Okay, let's go ahead and plot the points like we did on the problem beside it, the very first problem we did. 0, 1, 2, negative 1, negative 2. We will not color in the 0. I'm not even going to touch it. Don't worry about it. But I will put a circle at the 1, and I'll put a circle at the 2, and let's just be real honest, we could put a circle at the 3 and the 4 and the 5 and the 6, because all those are bigger than 1, right? And if you wanted to expound on this, 1.5. 1.5 is here, 1.5 is greater than 1, so yeah, there we go. And then 3 is greater than 1, 4 is greater than 1, infinity is greater than 1, so this goes forever to the right. Okay? Let's do the other side. Not 0, but definitely negative 1, and definitely negative 2. And actually, negative 3 made positive is 3. 3 is greater than 1. Negative infinity made positive is infinity. Infinity is greater than 1. So, yeah, it goes forever in this direction as well. So, where the less than shaded in between, greater than shades outward. Neat, huh? Yeah, it is. You know it is. All right, let's take a green pen and write our final answer. And it's not going to look like this. The lights just went out in here because I've been sitting so still for so long. Let's keep going. It'll be all right. I think you can see. So, actually, I can't. It's really dark. So, it may not look dark to you, but I'm trying to look on this paper, and it's just hard to see. I'll fix it in a second. X is less than or equal to negative 1. That's just taking care of this little piece right here. X is less than or equal to negative 1. Leave a little gap. And then we're going to do this piece. X is greater than or equal to positive 1. Greater than or equal to positive 1. So what I want to do is figure out what should go in the middle. And on this one, we kind of sandwiched our X in between those two values. And here, we have two separate pieces, right? So this was one piece, so we can write it as one piece. This is two pieces, so we write it as two pieces. And the word that we're going to put in between them is a mathematical word. There we go. The lights came back on. I had to get up and walk around. That's why I was screaming. The word we're going to write has to be very mathematically specific. And when we read it out loud, often we'd say X is less than or equal to negative 1 and X is greater than or equal to 1. Actually, I just snuck the word and in there, but the word and is incorrect. The word or is more correct. And here's why. If I said, hey, pick a solution, you would say, I can pick a solution from anything less than or equal to 1 or from anything greater than or equal to 1. But if I had the word and, it would have to satisfy both conditions. I will never satisfy both conditions because they go in opposite directions. So the word or is what I use here. Also, let's get even more technical. There is a mathematical symbol for or, and I just want to introduce you to it. It's this. So you could use this symbol. So when you're doing your work online, I think you'll have the option of using or this. And this symbol means union, which is basically the union of, like combining together, everything that could be in this solution set along with everything that could be in this solution set. And I'm going to put them together and just treat it as I could choose from this or that. Okay? All right, so keeping that in mind, we're going to do this one the same way we did this one without the table, though. We're just going to, you know how we looked at that and we're like, hey, let's see what we can do. Hey, let's see what we can do. So first thing we're going to do is, well, take this and look at that. See how similar they are? Absolute value of x greater than or equal to 1. X is greater than or equal to 1. Okay, cool. Oops. I don't need the absolute value bars there. I'm dropping the bars. Spitting bars too. I'm going to start rapping any minute now. X plus 1 is greater than 2. That's it. And that is our second solution set. Our first solution set, let's look at this. Just drop the bars. This greater than became a less than, and then this 1 became a negative 1. So everything I just said will work. Drop the bars. Greater than becomes a less than. 2 becomes negative 2. So it changes, like this changes and that changes. And then we'll just solve them. So I'd subtract 1, so x is less than negative 3. Or x is greater than 1. And I'll just graph those. So negative 3, 1. Okay, again, you're gaining a tremendous amount of skills and understanding of what absolute value means and represents and how to work through it logically. In a minute, I'm just going to show you some shortcuts on Desmos. And I know you're like, yeah, shortcut, Desmos, great. Desmos is a tool. Let's not be a tool of Desmos. I don't want Desmos to solve every single problem and keep me from gaining the problem-solving skills I need for problems like this, whether you use this in life or not. It sure would be a shame for you to choose a career in this and then never had those skills because you're too busy letting a machine do it for you. And if you don't even go into that career, there is a tremendous amount of mental growth that happens in this process. Really, there is. Just kind of looking at things logically. It's wonderful. Okay, we're down to the last 2. And I told you, you know the answer to this one. Actually, you know the answer to this one as well. So if you're going to follow along with what we've been doing, and you would be like, oh, well, this is a less than, and by the way, these 2 problems don't have too much room, but I'm going to try to do it. This is greater than. And before I finish my sentences about these, here goes. Less than problems are solved this way. Greater than problems are solved this way. It's that easy. It really is. Okay, here goes. Absolute value of x is less than negative 2. If you're like, oh, it's less than, we'll do it this way. Good luck with that. Good luck with that. All right, that's not going to work. And here's why not. That's negative. Here's what this says, and I'm going to write it in words. Absolute value is less than negative 2. Absolute value of something is less than negative 2. Stop. Think about that. Absolute value is always positive or 0. It could be 0. But either way, positive or 0. Either way, positive number 0, never going to be less than negative 2. This is false. This is a false statement. So without even doing any work at all, we know that there is no solution. Okay, let's do the next one. Absolute value, just writing it out the way it's read. Absolute value of something is greater than negative 2. Periods at the end of our sentences. Well, absolute value is always positive or 0. I'm just writing out what goes through my head. Positive numbers are greater than negative 2. Of course they are. 0 is greater than negative 2. Of course it is. So this is not no solution. This is every solution. Every solution. Meaning what? Okay, no matter what x value you pick, this is a true statement. No matter what x value you pick, this one's false. I could pick 5. Absolute value of 5 is less than negative 2. No. Negative 5. 5 is less than negative 2. Nope. Never. Never. Any number I pick will work here. 5 is greater than negative 2. Negative 5 becomes positive. 5 is greater than negative 2. Any number. So the final answer for this one, we're going to stick with our color scheme, would be all real numbers. X could be anything, and then, to get really technical about it, that's it. Shade the whole number line. Okay, down at the bottom of the page, there are some hints, and here they are. If solving by hand, you must first isolate the absolute value on one side of the inequality. We did not encounter that in this bad bad, terrible accent there. In this set of notes, in this side, on this side of the notes, we did not encounter that at all. But we probably will on the other side, do we? A little bit. So for example, we'd have to divide by -4 before we even begin in a situation like that, okay? Or if we had some other number like between this absolute value and that inequality, like +2, we'd have to subtract 2, okay? Less than creates an inequality that is between two values. Greater than creates two inequalities that go in opposite directions unless, and this is the exception with these bottom two, inequality is greater than a negative. In that case, solution is entire number line. Greater than a negative, number line. If an inequality is less than a negative, there's no solution.